All right, this lesson we're actually going to call 7.5 Day 1. You may have noticed that somewhere along the lines in Chapter 7, the trig functions of tangent, cotangent, secant, and cosecant all of a sudden kind of disappeared. It might have actually gone all the way back to Chapter 9, then we introduced all 6. And then all of a sudden, in Chapter 7, 4 of them went away, and we kind of got really into sine and cosine. The other 4 are back: tangent, cotangent, secant, and cosecant. And if we know sine and cosine really well and the properties of those functions, the other 4 tend to be easier, and it's less overwhelming to just focus on sine and cosine. All right. Let's just review what these ratios are. If we have a point on the unit circle that determines an angle, which we'll call theta, this would be y, this would be x, this would be r, okay? And it's worth reviewing here that we've seen that cosine of that angle is x over r, and the sine value of that angle is y over r. Well, tangent is y over x. Cotangent is that reciprocal, x over y. Notice here, secant is the reciprocal of cosine, and sine is the reciprocal of cosecant. Those ratios are just flipped. Okay? In a minute here, we're going to go evaluate some trig functions from these other 4, and we'll do it in the exact same manner that we did with sine and cosine, except there's a little bit of extra work involved. Okay, because our unit circle that we developed last lesson is really set up for sine and cosine. Now, we'll talk about this more in 7.5 Day 2, but when x or y equals 0, we get an undefined value at that point. In a unit circle, r is always 1. And at the very least, even if we're not dealing with a unit circle, r is never 0. So with cosine and sine, we never had to think about the possibility of an undefined value at a certain angle. These other 4, we have to consider that because x and y can take on the value of 0. I'm just going to throw that out there for now. We'll touch on that in 7.5 Day 2. Let's pay attention to quadrants. This is going to be a nice little diagram to have because the signs do become very important. Remember in quadrant 1, x-coordinates and y-coordinates are positive. In quadrant 2, the x-coordinate's negative, but the y-coordinate stays positive. Both are negative in quadrant 3. X-coordinate's positive, y-coordinate's negative down in quadrant 4. All right? Now notice we have them grouped here by reciprocals, okay? Remember, sine of theta is y over r. Cosecant is r over y. The sign won't be different. And it's worth noting here that r is always positive, okay? In fact, if we're thinking of this by the unit circle, r is always 1, okay? So the reciprocals always match. So for this first one, we're really looking at the y-coordinate. In quadrant 1, y is positive. In 2, it's positive. 3, it's negative. And in 4, it's negative. Okay? Maybe you want to pause at this point and see if you can fill in the rest yourself. In quadrant 1, cosine, and consequently secant, because both are based on r and x, positive in quadrant 1, negative in quadrant 2, negative in quadrant 3, positive in quadrant 4. Now, tangent and cotangent, we have to be a little bit careful because this is based on x and y. Now it's not just about one or the other, it's about the two being the same. Okay, because if we had a negative y value divided by a negative x value, that tangent or cotangent value would then be positive. Okay, here's what it means. It's positive over a positive in quadrant 1. In quadrant 2, we have one of each, which means tangent and cotangent values are going to be negative in quadrant 2. Things get a little bit strange down in quadrant 3. X and y are both negative, but that means tangent and cotangent values are positive because a negative number divided by a negative number is always a positive. Quadrant 4, tangent and cotangent are negative because we're back to one of each. Okay, you can see they each have their own, they're all positive in quadrant 1, but after that, they kind of all do their own little thing as far as each of those go. All right, so let's do a few of these. All right, we're evaluating. We're going to use the unit circle. We'll start by looking at tangent. All right, now just right off the bat, make note here, tangent of any angle. All right, it's y over x. All of these are going to be about key points on the unit circle. All right, so for these first three, it would be very, very helpful to have a unit circle handy. Okay, in fact, I'd say at this point you probably need one. At 120 degrees, what I find on the unit circle is the y-coordinate is the square root of 3 over 2. The x-coordinate is negative 1/2. All right? Y over x is tangent, so I take the y, I divide it by the x. I am not going to leave the answer in that form. Instead, I will multiply it by the reciprocal. Okay. And the 2's cancel, and I get negative square root 3. Okay, I'm going to block that off. So you know that all goes with problem 1. Negative square root 3 is the exact tangent value for 120 degrees. Next up is secant. Okay, and again here, just be thinking about what this particular trig function is. Secant of any angle is always r, which if I'm working with the unit circle, that's 1, r over x. Okay, so for the secant of 225, r is 1, and then the x-coordinate associated with 225 degrees would be negative square root 2 over 2. Okay? Essentially what I'll do here is flip this and make it negative 2 over square root 2. I'm then going to rationalize it. I'm going to start moving down here where I have a little more space. Again, let me get this blocked off so that we know that this has nothing to do with cosecant of 7 pi over 6. Then we get negative 2 square root 2 over 2. The 2's cancel. Negative square root 2 is the cosecant value for 225 degrees. Okay? Really comes back to this. Do you know your ratios? You got to know that tangent is y over x, that secant is r over x, and this type of thing. Okay? It's not as easy as it was for sine and cosine, where we just, all we need is the x or the y value. There's a little bit more work. That's why I was saying earlier that the unit circle is really set up for sine and cosine. It's made to be easy for those, but here we have a little bit of simplifying that we have to do. Cosecant of any angle is r over y. Okay, cosecant is the reciprocal with sine. For 7 pi over 6, again, we know r is 1, but the y-coordinate at that point on the unit circle just so happens to be negative 1/2. I can flip that, and there I'm actually already done because I got negative 2. Negative square root 3 is the tangent of 120 degrees. Negative square root 2 is the secant value of 225. Negative 2 is the cosecant value of 7 pi over 6. Okay, all based on the unit circle, but we do have a little bit of extra simplifying that we have to do. We've already talked in class about using the calculator. That's what's going on here. If it says round to 4 decimal places, we're using a calculator to do it. One thing I do want to point out here with these is on a calculator you will see that there's no cotangent value. Remember that cotangent is reciprocal with tangent. There is a tangent value, so what you really need to type in is 1 over the tangent of 165 degrees. Same thing with cosecant. You can look all over a TI-84. You're not going to find a cosecant button. That's a reciprocal with sine. Now this is in radians because there's no degree symbol. So I'd have to make sure my calculator is in radian mode, and I would evaluate 1 over the sine of -1. Okay, that's how you would use the calculator to use the other trig values. Obviously, if you had a secant, you would do 1 over cosine. Okay, we're going to call it quits there for 7.5 day 1. That's the basics of evaluating trig functions for the other 4 functions. Again, the other 4 meaning not sine or cosine. We'll call it quits there. Make note of any questions and be sure to ask about those next time we see you in class.